Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Before we get going, I'd like to send a huge thanks to our friends at HPE for sponsoring this week's series of shows from the O'Reilly AI Conference in New York City. At the conference, HPE presented on InfoSight, which is the company's cloud-based AI ops solution for helping IT organizations better manage and ensure the health of their IT infrastructure using AI. I've previously written about AI ops, and it's definitely an interesting use case for machine learning. To check out what HPE InfoSight is up to in this space, visit twimlai.com/HPE. All right, everyone, I am on the line with Delip Rao. Delip is the Vice President of Research at the AI Foundation. Previously, he founded the research consulting company Juiceware and the Fake News Challenge as well. And he's one of my favorite AI people to follow on Twitter, where he tweets from @Delip Rao. Delip, welcome to This Week in Machine Learning and AI.
Thank you for having me.
I'm really looking forward to our conversation. You recently joined the AI Foundation, where again, you'll be leading out research. Tell us a little bit about your background and what sparked your interest in AI and in particular, natural language processing.
Yeah, absolutely. So my background is in research, particularly in natural language processing research. And I grew up in India. I did typical engineering track that a lot of kids in India do. And I was pretty sure I was going to become some kind of an academic very early on in my career, in my college life. And because I found teaching very inspiring, and I really wanted to be a teacher. And AI was not my choice in the beginning. I actually wanted to to do research in distributed computing. And I realized that, there was this one school where I went, IIT Madras, and there was a faculty who was working on distributed computing, and he was on a sabbatical. So they kind of like put me in charge, in care of another faculty who was working on AI. And this person was supposed to babysit me while my actual professor, returned back from sabbatical. And he did a very dangerous thing. So he gave me a couple of books, thinking that it'll keep me busy. And I just got really hooked. So after reading this couple of books, I just felt like, okay, this is what I should be working on instead of distributed computing. And that's when I started working on AI. And this person was actually like a very hardcore, like old school AI person. Like we were working on like planning problems and so on.
Okay.
So I actually started looking into AI planning actually to begin with, and actually looking at search algorithms and so on. And it was only like around that time, I just got like curious about natural language processing, because the data that we were working with involved text, and natural language processing was supposed to be some kind of like pre-processing I was supposed to be doing, but instead I found the pre-processing itself super interesting. So I kind of moved into natural language processing, and then I went to graduate school because of that. Like, I felt like, I have to study more, and this is all ancient history, by the way. So,
do you happen to remember the name of the books that your babysitter professor gave you to read?
So I think one of them was actually the book by Nils Nilsson, who recently passed away, like I think as recent as yesterday or day before.
Oh, wow.
So he was a professor at Stanford, and he wrote one of these very early AI textbooks. And then there was also the classic book by Peter Norvig, and Stuart Russell and Norvig, right? So yeah, I started off with those two books. The Nils Nielsen book is like a really great gateway drug for anyone. I highly recommend. So then of course, the Peter Narvik book, puts you on a more serious route.
And so I think we veered off at grad school. Did you start Juiceware right after grad school?
No, far from it. Actually, I worked at a bunch of different places.
Okay.
I worked at Google Research as a kind of like a repeat intern, and then I went to Twitter. And at that time, Twitter was pretty early, and it was way before their IPO. I was like a employee number 500 something, and. Yeah, I was one of the first machine learning hires to join their anti-spam team, and they were until that point. And they just formed a anti-spam team when I joined, a few months ago, and they were writing all sorts of interesting rules to catch spam. And I was like, oh no, that's not how it should be done. But actually, I got schooled because I felt like, oh, I came in waltzing, thinking that here I am with all my training. I'm going to go change the way things work. But then that's when my first humbling experience happened. I discovered that real products don't work that way. You can't build like simple models that will that you can just unleash it on the world and expect it to work. And they were doing a lot of things coming from deep experience, product experience. And that's when I kind of like completely shifted from my academic researcher mindset to a more product-based researcher mindset.
Are there some specific examples you can give of where that disconnect really fell for you?
Oh, yeah, absolutely. I mean, like, for example, dataset drift is something that we kind of barely refer to in academia, right? And the model drift. Model drift is something that we barely refer to in academia, but it actually happens all the time in production. Your models stop being relevant, and you have to kind of figure out some kind of a feedback loop to start to keep retraining your models. And even sometimes, there is this, when you don't know much, there is a kind of a cockiness that comes in where you say that, oh, you can build this model, you can solve this easily by building a model. But then you realize that getting the model done and building all the engineering around the feedback loop for the model itself is so much more expensive than sometimes even writing a few rules or writing something very simplistic, which to a researcher, especially coming from an academic background, it almost feels like, oh, why are we doing this, right?
Mm-hmm.
This is not science. Why are we doing this? And this is more importantly, I think in academia as well as in research, we're always encouraged to stay, push the envelope and stay ahead of the game, right? And when you see some heavily engineered system built using rules, the natural feeling comes in thinking that, oh, this is all outdated, it's kind of very natural for somebody coming from academia to look at it and feel a little like this is all outdated stuff.
Mm-hmm.
But I think with experience, there is this enlightenment that creeps in where you realize that no, actually, that the so-called outdated stuff is actually the most appropriate thing to do in this context. And that's when, I kind of, it took me a few experiences like that, right? One, of course, I gave you an example of model drift. Another is you build a model, the model does really well, then you're very proud of it. And then you try, and then, in a company like Twitter, everything gets A/B tested carefully. And you end up also not just getting A/B tested, but also you're tested for how much compute that you're setup is taking, right?
Right.
Because you're operating at that massive scale. And if a simple rule-based thing is accomplishing pretty much everything that your model thing is doing, and your model is just adding like, a few decimal point improvement or a few, even like a percentage point improvement, it becomes a wash, but it comes at an enormous cost to the business, right?
Mm-hmm.
And so it just does not make sense. And as a researcher, you don't think about that because you're always looking at like, oh, can I improve on state of the art? And even if, as long as the improvements are statistically significant and I can publish, I can call it a win. And that's where like, a disconnect happened for me. And I kind of, I felt like, oh, there is a different way to do science that is relevant in the real world, and I want to practice that.
Have you developed that to the point where you've got some kind of fundamental tenets of science in the real world, or is it more a general idea and approach?
Yeah, I did. Some of it I kind of allude to in the book that we published. We can talk about it later. But, I was going to say that I worked at Twitter and then I worked at Amazon, and Amazon was also another amazing experience. And it taught me a whole bunch of different things along similar lines. And after spending time at these two places, I started Juiceware, which was a research consulting company. And it was a research consulting company kind of built with that mindset, right? When you do science that will be baked into products, it has to be developed differently than the science that we do typically in graduate school labs that's meant for writing a paper. Mm-hmm. And that was the mindset with which, Juiceware was created. And in fact, all our clients we worked with, we actually built solutions that could be deployed. Not a single solution that shipped from us was like, paperware or shelfware, right?
So you mentioned the book, and I had this on my list of things to mention in your intro. So I'm remiss in that regard. You just published a book. In fact, it's sitting here on my desk, Natural Language Processing with PyTorch, which you co-authored with Brian McMahon. And so we'll definitely dig into that a little bit more. You recently joined the AI Foundation, which I hadn't previously heard about, but read a little bit about. And it's got this interesting kind of for-profit, non-profit structure. Reminded me a little bit of kind of some of OpenAI's recent announcements in terms of the direction they're going. Can you tell us a little bit about the AI Foundation and kind of that structure and what the organization is up to in general?
Sure. In fact, the funny thing is now people are referring to, using OpenAI as an analogy, but we established the structure almost like more than a year ago.
Okay.
And in a way, I think this is great for mission-oriented companies. AI Foundation is a hybrid for-profit and non-profit. And the for-profit, we are actually interested in building all kinds of synthetic content. And in the non-profit, we are actually interested in detecting the synthetic content. So actually, we started off with, or at least the founders, they were interested in solving the detection problem. But then, you can't just go off and build a nonprofit and keep it sustainable, right? You need something to power the nonprofit. And a for-profit is like a very sustainable way to power a nonprofit. Like before I started started working at AI Foundation, I started the fake news challenge in a very nonprofit mode. And that was not easily sustainable just based on grant money. Sure, we won some grant money from Knight Foundation and so on, but it becomes a massive exercise, almost like and it's not a sustainable way to build a nonprofit. So when I learned about AI Foundation and I learned that about their mission, which was to detect any kind of synthetic media on the internet or anywhere. And it includes generated video, generated audio, as well as generated text. I was obviously very excited about that, and then I was curious how they were actually approaching it, and actually it was their way of approaching that may sold me more than the mission itself, because I was already sold on the mission. I kind of even before I discovered AI Foundation.
Mm-hmm.
So the for-profit is building products, like is doing all this interesting synthesis work in the context of AR and VR, right? And this is great because one of my experiences that in order to be really good at detection, you also need to be really good at generation. And the way the for-profit and non-profit is structured is that, the for-profit is actually building technology that is so strong at generation that the non-profit, the technology the non-profit is building also gets strengthened, kind of like a real-world GAN, if you will, right?
Mm-hmm.
They're both reinforcing each other. And of course, it helps for the for-profit folks to go spend some hours working on the nonprofit stuff, and it's a really great model.
Sounds like there's some commonalities between the kind of problems you're trying to solve with the fake news challenge and what you'll be working on at AI Foundation. I'm curious, what were the key takeaways from your experience launching the fake news challenge and conducting that?
Oh, yeah, absolutely. Fake news challenge was another one of those humbling experiences in life. And I think this is great. Everybody should go through multiple such humbling experiences. And that's where a lot of growth spurts happen. So when I started seeing around the 2016 elections, when I started seeing a lot of misinformation on Twitter, I'm very active on Twitter, as you know, and I have been for quite some time. I felt like, oh, there is all this misinformation coming. Why is Twitter not doing anything about it? Why are these platform companies, especially Facebook? At some point, I used to be on Facebook, and I was seeing a whole bunch of random, complete conspiracy theory,
Right.
nuts stuff being shared on Facebook. I'm no longer on Facebook, but I just felt like the platform companies were letting us down by not working on this problem. And
Mm-hmm.
there was also a time where, Mark Zuckerberg went on stage saying Facebook does not have a misinformation problem,
Mm-hmm.
right? This was in 2016. And around that time, there was not just me, but a whole bunch of other people who were interested in this problem started talking on Twitter. And I ended up partnering with Dean Pomerleau. He was a professor at Carnegie Mellon. He was one of the pioneers of the autonomous driving program developed by DARPA. And he was doing self-driving cars in the 80s. It's crazy to think about that. So anyway, Dean and I started the fake news challenge, and we both were we are both entrepreneurs, right? And we have this sort of entrepreneurial optimism. And at the same time, we are academics. So with academic background, we think that we can solve anything.
Mm-hmm.
And we thought that, we can totally build some kind of natural language processing system to kind of detect fake news. And it didn't take us too long to realize how nuanced this problem is. And the more we started talking to fact checkers and journalists. I spent, I don't know, I can't even count how many hours with fact checkers and journalists. And I realized that, gosh, this problem is so complicated and the work they're doing is so complicated. It's not going to be any one system or approach that will solve this, but it will be a combination of approaches involving modeling, it involving human in the loop, etc. And that's when when we started fake news challenge, we thought we were going to come up with a solution, right? And
Right.
that was like the kernel of the idea, that we'll come up with a solution. And then, we thought, oh, maybe it's not one solution, it's multiple solutions. Then we thought, no, it's not even multiple solution. What you want is a community of people talking to each other. And that will create like a factory for coming up with multiple solutions and create more conversations, right? And so Fake News Challenge ended up becoming this sort of like a open community where researchers interested in natural language processing, computer vision, etc., and also the fake news problem could come and interact with journalists and fact checkers. And basically, these were until the Fake News Challenge happened, there were two different communities that were not talking with each other as much as they are today, right?
Right.
And I'm not claiming that, the Fake News Challenge completely changed that, but I think it set the tone. And as a consequence, what happened was there were a lot of people who ended up meeting there. Some of them ended up starting their own companies around this space. Some of them ended up starting other events around this, and it created a whole bunch of conversation. And I think there is like a snowballing effect that happened after that very shortly. So I think your original question was, what were the key takeaways from the Fake News Challenge? I mean, the one takeaway was like, always be humble, like keep, the world is more complex than you initially think it is. And there are surprising ways in which we keep learning that and relearning that. And the other, takeaway is we found that, okay, we put together this community. This community needs to be engaged. We need to do something about it. So we created a shared task, and I would like advise anybody to not take up this job of creating a shared task. It's one of those really complicated jobs that require multiple people working together in order to pull it off like really well. And despite me working on it full time, and even Dean spending a fair amount of his time on it, it was super challenging to pull it off, right?
And the shared task in this case is the creation of the community or the creation of a solution to the problem?
So what we did was I put my consulting hat on, and then I looked at, okay, I'm going to talk to a whole bunch of fact checkers, and I'm going to find out what are the core problems that they are dealing with, and if there is any science problem that needs to be solved in order to solve this problem, right? And I, it was obvious that one of the common problem that kept coming over and over was that of volume. So almost all fact checkers are like inundated with articles, and they need to fact check. And many of these articles are like, pretty much rehashing the same thing or different variations of the same theme. And therefore, they can't be very efficient about how they fact check, right? And how they assign labels to these articles or any kind of additional context around these articles. And what we did was we created a data set where if I give you two articles or let's say two pieces of text, can you tell me if the two are related, unrelated, discuss about about the same topic, or they contradict each other, right? And it's a surprisingly hard natural language processing problem, right? Like it's, maybe not it's unsurprisingly hard natural language processing problem because you're not just solving textual entailment, you're solving a whole bunch of other things in order to get it right. And a lot of teams competed on it. Again, it's not one of those things where the data set is still out there. It's not like an MNest or something where people have solved that data set and moved on, right? It's a really hard, challenging problem. In fact, the problem was quite so interesting and challenging that it got used in a lot of university NLP courses, ranging from MIT to Stanford, every big and small university departments offering NLP courses in class projects and so on. People have published on the data set. So the shared task was actually like a great way to keep the community engaged. But man, it's really time consuming to actually get that done and to make sure the evaluation, etc., was happening. Right. And we kind of I wanted to throw in a little more excitement to this. So Justware decided to sponsor like prizes for the top three. And it became quite successful. There were more than 1,000 people who registered for the challenge. I forget the exact numbers now, but there were like a few hundred teams actually competing in it. We had to, it was all automated, the evaluation, etc. And we ended up, finding the top three and awarding them prizes and so on. And I would say the learnings from the fake news challenge were, one half was technical. I would say as it was as much non-technical as it was technical. The non-technical or softer aspects were like the domain-related problems, like how complicated the domain is and who are the key people working on the domain and how we can facilitate, and how to build a community and how to sustain the community and so on. And the technical parts of the thing is actually, to me, somewhat least interesting. I guess it was more like, how do we come up with a data set for this situation? And we came up with some interesting tricks to build the data set. But yeah.
And the competition ended a couple of years back. I'm curious, do you think that the data set and the competition is still relevant? And are the solutions that were proposed at the time still relevant? Or do you think if you miraculously could clone yourself to run this thing again, would you see dramatically different results 2 years later?
So the shared task by itself as a natural language processing task is still highly relevant. And the approaches that were proposed, they were all unsurprisingly deep learning based approaches. They're all still relevant. Maybe today, if you were to do this, you would use something like BERT or some of these beefier models. Mm-hmm. But other than that, the fundamental approaches are still relevant. That said, when we created this shared task, we called it FNC1 for a reason, because we realized that none of the tasks that we propose is going to be representative of a fake news solution, right? In fact, any solution to the fake news problem is actually coming from a multi-pronged approach, and there are so many problems to be solved. So the volume is just one aspect of the problem. So we call it as FNC1 for that reason. So which automatically implies, will there be an FNC2, FNC3, and so on? Right. And the answer is yes, because it takes such a lot of effort and thought to put together an FNC2. I am actively working behind the scenes, talking to people around what this FNC2 should be like, and how to make that relevant to the new kinds of problems that are facing, because the kinds of vectors that are popping up, right, especially with around the deep fakes and things like that, there are different kinds of misinformation vectors coming up. How do we select a task that faithfully reflects what is happening today?
Yeah, let's jump into kind of the current state of fake content generation and detection. There's fake news as you kind of traditionally defined it in FNC1, and there's a bunch of sub problems there. You mentioned deep fakes. When you think about the content generation and detection landscape, what do you see as the primary challenges, and how do you organize all of that in your head?
I guess, practically every modality can be faked. That is audio, video, text. I guess maybe tomorrow, if tactile becomes another modality, you can fake that too. I don't know. So right now, at AI Foundation, we are interested in detection of all three dominant modalities, right? Like audio, video, and text. And each of these have their own approaches for generation. So, for example, with video, you might already know about a whole bunch of approaches based on GANs, right? So these generative model approaches. And then there are all these approaches based on image-to-image transfer, like face swap and deepfakes and so on, right?
Mm-hmm.
So that's one category of misinformation. Another category of synthetic misinformation is like in audio. You can Tacotron set the trend, but like the latest WaveNet models have become so good that you have to be not a human to detect if an audio is coming from a model or if it is coming from a human person. Right.
Mm-hmm.
And I would say three ways to generate fake audio. One is synthesis, that is obvious. Another is voice conversion, where, I can take your voice and then kind of like pass it through a deep network and then, do a style transfer to somebody else's voice.
Mm-hmm.
Right. And so that way I can give you a power to say in anybody else's voice. And the third is, of course, replay attacks, right? Where I can splice a piece of audio from a previous conversation in a different context and kind of like create confusion because I can make you say things out of context, right?
Right.
And the replay, so the first two are actually, you need a model to detect that because especially with lots of compute and a lot of parameters, like, really deep and wide models, you can model, like you can generate audio with really high fidelity that the human ear basically cannot distinguish, right? Like, and we are doing some experiments around that too. But what we see is many of these generation algorithms, right, like synthesis or voice conversion algorithms, end up leaving some high frequency artifacts in the data, in the audio, that whatever your ear misses, a detection model can easily pick up on, right? So I mentioned two of the three audio-based, two of the three methods to generate fake audio.
Mm-hmm.
There is also a third method, which is the replay attack. And interestingly, the replay attack has become it is one of the oldest attacks, right? Because you don't need a model to do that, and it's been happening forever.
Right.
There has been a lot of work on detecting replay attacks. And in fact, ICASP in last year, they had a challenge for detecting replay attacks. And basically, not last year, in 2017, they had a challenge in detecting replay attacks. And 2018, and their error rates were around 2.5%, right? Where they were able to ensemble all the top models, and then let's say, the ensemble error rate was around 2.5%. And in 2018, there was this one paper, I can give you the reference if you want, where the error, basically went down to zero. So interestingly, we can now, with the help of models, almost always detect replay attacks. And that's possible because whenever audio recording happens, there's always a whole bunch of differences that are, channel and room, ambience related variables. That
all kinds of low level acoustic qualities that are undetectable by us, but
but the model can easily pick up that change in that when you kind of like splice another audio into an existing audio.
So on the audio side, are there what does the data set landscape look like for, folks want to play with this? Are they creating their own data sets, or are there some interesting
So
public
far,
ones?
no, there hasn't been any other data set I know other than ASV spoof, which was put together by a bunch of other researchers and Google. I think the Google synthesis team is behind the ASV spoof data set. And basically what they're doing is they're collecting a whole bunch of different synthesized audio and audio that has been synthesized by whole different kinds of
All these three
systems.
methods?
Yeah, all
or
these
just
three methods.
synthesis?
I think they're only using synthesis and voice conversion,
Okay.
not necessarily replay, because replay I feel is like probably nobody wants to work on it.
Yeah. Probably easier to create your own data set for that too.
And also replay is kind of like a solved problem, with whatever caveats, right? But sufficiently over parameterized network, we can easily detect a replay attack. But the other two require some amount of work. And I think this is actually the current ASV spoof, like 2019, where detecting whether the audio came from whether it came from a synthesis system or a voice conversion system. Or another interesting task is actually, can I detect change in the room parameters, right? So imagine, let's say I have your Alexa, right?
Right.
I'm able to record you in a different room. And then let's say I'm talking to you and I make you say something and I, clandestinely record it. And then I go off and play that recording to your Alexa and make it purchase like, I don't know, 10,000 Barbie dolls or something like that. So if you do that, how can you detect it, right? So can I change? So you can kind of like generate audio by automatically changing the room parameters, like different kinds of audio by generating. You can by varying the different room parameters, like the size of the room, the position of the speaker, and so on. And that will change the reverberation, and that in turn changes the quality of the audio, and so on.
It's interesting to think that, a retailer, for example, a particularly e-commerce retailer, has long since had, huge anti-fraud teams that are working on credit card fraud and other types of transactional fraud. It's interesting to think of how, an Amazon or a Google now might resource audio fraud because of the kinds of scenarios you're describing with Alexas that they're putting into everyone's house.
Yeah. So, and this is a big problem for like a lot of banks in accepting, and credit card companies in using audio-based or voice-based authentication, right? So any speaker verification system can be foiled if it's not carefully planned. It can be foiled by doing some kind of a replay attack, because most of the time it's something like my voice is my password or something like that you end up saying, and if it is recorded under sufficiently high quality conditions, then I can use a replay attack and basically foil any voice authentication system.
Well, we'll come back to some of the other modalities, but you previously alluded to this kind of the GAN relationship between generation and detection in the context of audio, but I imagine this will apply generally. How do you see this interplay kind of evolving between the detection and generation approaches and systems? Like now that we're getting so much better at synthesis and conversion, detecting synthesis and conversion attacks. Are we already seeing, feeding that back into the synthesizers and converters and trying to make better systems?
Yeah, and that's going to be an arms race, and we have to accept that. So the better the detectors become, you can imagine somebody with sufficient motivation, and it's not difficult to find them, actually engineer systems to overcome that or figure out exactly, okay, how do I foil these detectors? I think an interesting challenge that's not yet been conducted by anyone is look at all the approaches to detection and come up with ways to break them, right? And I think that will give us a lot of interesting lessons into building more robust detectors. And this is true with any kind of adversarial setting, like, starting from fighting spam, like anti-spam. So you come up with one approach to, like, let's say you figured out that, a lot of the Nigerian spam emails that you get, they are using poor language, right?
Mm-hmm.
And you try to, let's say you train some n-gram based thing that detects it. You say, okay, the perplexity is too high, therefore this could be like a signal for spam. But then guess what happens? They will start copy pasting. They won't even have to do like fancy generation. They will copy paste like chunks of good text from different places and file the detector, right?
Mm-hmm.
And now that that is happening, you'll start moving the detector in a different direction. And I think this is the game of working in an adversarial learning setting, that your attack vectors keep changing, and you have to constantly keep monitoring the attack landscape and then keep evolving the solution.
We're starting to explore a lot of this ground in the context of adversarial examples on the video side. There's a whole body of knowledge for, I guess, kind of meta knowledge for dealing with these kind of adversarial scenarios in the security research world. Like, do we have enough of that DNA within the kind of AI and NLP realm, or are we starting to get enough of that we can, we're not reinventing the wheel?
We have for some, like, in NLP, I can say because of things like anti-spam, etc.
Mm-hmm.
There has been that kind of work happening already, right? Like,
Mm-hmm.
Around phishing and around spam, people have been constantly building systems that involve some kind of a feedback loop and preferably a human in the loop. That way, you can sort of deal with this shifting adversary. And we'll see similar things happening with these other modalities as well, right? Like, so that's not, that's pretty much on the roadmap for any serious company.
So we dove into audio. On the video side, what's the landscape looking like there? I think deepfake is the thing that comes to mind, but even that is somewhat ill-defined and includes a bunch of different types of things.
Right. So, like, for example, like anything that is generated or sampled from a GAN, today, even the best GANs still end up leaving some kind of artifacts that it makes it possible to do good quality detection, right? But I can imagine a future where compute becomes so easily available and maybe a different kind of modeling paradigm where we are basically able to generate hyper-realistic image or like even photorealistic, very uncanny images, right? And the thing about detection is I have this thesis that all detection models are always better than humans at detection when it comes to sophisticated attacks, right?
Mm-hmm.
And as things become more. So initially, we will have, we'll operationalize it. We'll have more and more people looking at things and so on. But then once the adversaries evolve and then they decide to launch more and more sophisticated attacks, then models will become indispensable for doing that, right? And so I think we are seeing some of that happening with GANs. And now with GANs, you can there are all these temporal GANs where you can actually generate a sequence of images that are tied to each other, so that it becomes like a video, as opposed to individually synthesizing each frame, right? I think that was one of the criticism with that, with GANs. But then there is also, you don't need a GAN, right? With things like celeb fake, etc. There are things happening which are a class of algorithms which are doing this image to image transfer, right? Where I can basically take your body and then just swap out your face, or sometimes even just swap out the lips, right? And then make you say things that you have not said, right? And that's interesting because we're a lot of the algorithms that we're working with, even the state-of-the-art methods, are still leaving some artifacts that models can detect. At AI Foundation, we have research as well as like a product that we are working on, and from the nonprofit side, where we are detecting manipulated faces in video and showing a heat map over it, right, and so on.
Efficient frontier may be overloading a term, but there's a kind of a frontier where the cost to generate these things and the quality, the resulting quality, versus a human's ability to detect. It seems like we're still in a different place than where audio is. Most of the things that are accessible that I see are pretty, it's pretty easy to tell as a human that, this is a bad fake.
Yeah. But I would say that, with GANs, when I say human, when you say humans, we have to be careful, right? You and I are probably looking at people like us who tend to be more in the machine learning AI world. And we are used to seeing a lot of these things, and we kind of have this innate expertise to tell them apart. But we have experiments we have done with human subjects where, there's human subjects who are completely non-technical. When they look at GAN images, there's literally a 50-50 chance that, they get it right. Yeah. Wow. And this is where, I think a model becomes highly valuable. It gets worse when it becomes audio. With audio, practically everyone will fail.
You made a comment and refer back to it that we're going to be dependent on models because humans are, we're being outclassed by models. And it makes me think a little bit of, there's been some research on medical imaging that says that, a model is, X% accurate at, say 80% accurate at detecting some cancerous, growth in an image. A human is 80% accurate. I'm making up the numbers here, but together they're 95% accurate or something along those lines. Do you think the same thing will evolve in fighting artificial content, where humans plus models become the ultimate solution?
Absolutely. I feel like that's an inevitable case where humans and models work together, except that I would make a small note that in that situation, the kind of information that a human might be different from the kind of information the model is looking at. Right?
Do you have some examples come to mind?
So, for example, in this case, the model might be, let's say, take fake audio, right? The human may not be able to tell apart the fake audio from a generated one, let's say. Right. And sometimes, with compression in audio, it can get even worse. Like compressed images and compressed audio introduce all sorts of artifacts that you cannot distinguish between that from the artifacts that you get from a generated system, from a system that does synthesis, right?
So we're kind of conditioned to accept some degree of compression artifact, and so
exactly,
got it.
Exactly, and folks really have trouble telling that just from the content, right? And so the models will look at things that or listen to things that people can't listen to, or see things that people can't see. But at the same time, let's say the model flags something as doctored or forged, then we can imagine a human in the loop actually looking into it and not necessarily looking at the content, but looking at everything else, looking at the context, where is this coming from? What is the user behavior? And so on, right? To a large extent, it can be automated, but even the context, it requires a lot of background knowledge as well as knowledge of the world to be able to say to make a definite pronouncement. And we see this all the time in I will give you an example from the spam world where I come from. So if you have training topics, right? So there is a lot of things appear like spam. The model can flag it as spam, but if you know that this thing is actually related to a training topic, then a human can make a judgment call whether to mark it as spam and take a retaliatory action, like by suspending the account or something like that, or whether to just treat it as simply a high volume traffic because this trending topic is just so engaging and so controversial, right?
Right.
And this is a call that a human and only a human can make, at least as far as now, because the context is where it requires all sorts of reasoning and unification with the world that it's hard to bake that into a model.
I feel like we were just scratching the surface here, but we're running long on time. I do want to briefly mention once again the book. If I remember correctly, there was a tweet. There were probably multiple tweets along these lines, but I remember you tweeting something along the lines of your philosophy with the book, or at least one aspect of it, relating to the code examples being real examples or something like that. Can you elaborate briefly on your philosophy for the book and what makes it different from picking up a tutorial on the web or on YouTube or any of the other books out there?
Yeah. So when Brian and I set out to write this book, we decided to bake in all the best practices that we were actually practicing on a day-to-day basis. And also, we were not seeing them on any of these tutorials on the web and so on, or also on the original documentation. So we decided that, there are very good software engineering patterns. I mean, I've always believed, because I come from a very engineering background, I was an engineer first and then became a researcher. I think really good science requires good engineering, and good engineering is indistinguishable from good science. And it's important to have the two together. So we baked in a whole bunch of best practices that we knew of from the software engineering world to actually make modeling good, modeling successful, right? And so if you follow some of the practices that we suggest, you would not make a typical modeling mistake that you'd spend days, if not weeks, trying to chase down, right? So that's what I meant by real world. And then, of course, a lot of this actual problems that we have chosen, we intentionally chose problems that were not like toy problems, right? Or toy data sets. Any of our data sets could be comparable to the real data sets that anyone can deal with. Mm-hmm. And it's just a question of like, how do we come up with a set of representative tasks for the book that pedagogically it will expose the readers to a variety of NLP deep learning algorithms, and at the same time, not take the reader too far away from their home court, which is the world of practice, where the world of real problems. And I want them to be situated next to each other. And hopefully, if we did our job right, we have shown the readers a lot of good software engineering practices around building models, and we also talk about like good design patterns, not just from building models, but even for the product, building NLP products itself. Mm-hmm. So in a variety of ways, this book is actually built for practitioners. It is a book that is built for anybody who is good at Python development to pick it up and quickly become familiar with natural language processing and deep learning and the combination of the two, and become proficient enough to go do their own research. And this is something I strongly believe in. A lot of people have also believed that research is something that you can learn on your own, and you don't need to go to graduate school and all that, like the fast AI folks and so on. Mm-hmm. And we believe in the same thing, except we believe we express it differently, and in the sense that we think there is a lot of value in graduate school, and of course, and in all the research that is out there. And there is a lot of value in reading papers and actually even writing papers. But there is all that has to be done in the context of real world product development setting. And every single course that I am looking at today is failing on that. Right. Mm. And I'm hoping that, the book that we wrote is just scratching the tip of that iceberg.
Well, Delip, thanks so much for taking the time to chat with us about what you're up to. Very interesting stuff. And we will be sure to continue to follow along.
Absolutely. This was such a pleasure. And, my God, time just flies.
Yeah, my pleasure. Thanks so much.
Yeah, thank you.
All right, everyone, that's our show for today. If you like what you've heard here, please do us a huge favor and tell your friends about the show. And if you haven't already hit that subscribe button yourself, make sure you do so you don't miss any of the great episodes we've got in store for you. For more information on any of the shows in our AI conference series, visit twimlai.com/AINY19. Thanks again to HPE for sponsoring the series. Make sure to check them out at twimlai.com/HPE. As always, thanks so much for listening, and catch you next time.